Hello, I'm Michael Littlecrow. I'm your instructor for Math 170. I had a student ask a question about if I could explain even and odd functions. So this will be a brief explanation of this. Now, there is a video that does explain it in terms of f of x and f of negative x and what those are. Let me give you just sort of a quick view of how I've seen it and I learned it. That helped me tremendously. First of all, even functions, if it's a polynomial, what that means is all the exponents will be even. So an example, f of x equals 3x squared is an even function because the exponent is even. Example of an odd function is going to be something like g of x is equal to, say, 2x to the third. And again, this is an odd function because the exponent is odd. It doesn't matter about the coefficients. It's only looking at the exponents. So what happens if we have more than one exponent? Well, let's come back here. So if we have more terms, so f of x equals 5x to the 8th plus 3x to the 6th plus 4, let's say x squared. All the exponents are even. There's an 8, there's a 6, there's a 2. With all even exponents, this is an even function. Finally, back here, same thing could happen with g of x. We could make this all odd. Again, we could have 7x to the 7th plus 3x to the 5th minus 2x to the 3rd. All the exponents are odd, so this is an odd function. Now, one of the examples given in the other video was a trig function. We will get to those later, so I don't think you're going to see any. If you see any in this section, shoot me an email. I haven't gone through every single problem, but trig is supposed to be the second half of the class. Okay. Now, there's one tricky point. What if there is no exponent? So, like there's a constant at the end. Well, I'm just going to give you the answer on that one. It's going to be, in this case here, this case over here, it's going to be even because a constant basically has a variable to the 0 power. Okay, so let's just go f of x. Say, let's start with our 3x squared, which we know that so far is even, but what if we say subtract 1 from it? Now, hopefully you've seen, we'll see transformations. What this is a parabola that's been moved down one unit, so it's still got symmetry about the y-axis. That's what the definition of an even function is, symmetry about the y-axis. So this u shape gets moved down. It's still going to have that same symmetry. The other way to think of it mathematically is that this last term, we'll go with yellow, this is really, there's an invisible term here. This is 3x squared minus x to the 0 power. And just sort of by definition, 0 is an even number because it's on the 2, 4, 6, 8. And if we went the other way to the negatives, it would be 2, 0, negative 2. So it's on the even. 0 is even. Let's just put it that way. And that's all there is. So what happens when we get a function that has both even and odd exponents? Well, that's the third case. It's neither. It throws off any kind of symmetry there would be. So even functions have y-axis symmetry, so that's kind of a U shape around the x on both sides of the y-axis. Odd functions have what I want to say, they have symmetry around the origin. So I like to think of it sort of as a spinner. So, you know, a cube is going to look like, it'll graph something like this, and I apologize, my drawing skills are not the best. That's why I'm not an art major. I would have loved to be a good at art, but anyway, so we kind of get this sort of thing where if you were to spin it around 180 degrees, it would land on itself. And a cubic does that, so that's the kind of symmetry it has. So where the first quadrant is similar to the third quadrant. Okay, so that's odd symmetry. Neithers happen when we get some kind of a function, we'll just call it h of x, and where we could, a good example of this would be something like 2x to the third. Let's just go, like, say, plus, we could do plus 1, 2, let's just go plus 5. And again, what this did is it took a function that had origin symmetry and it moved it up 5. So it would look something like this. So it's no longer symmetric about the origin. It's because it's been moved off the origin. Okay, so that's what this does. And from our previous experience with this x to the 0, that's exactly what's happening. This is really 5x to the 0 power. So we've got an odd exponent, we've got an even exponent. This is a mix. In this world, it just throws off the symmetry. So this is a neither function. Even, all exponents will be even. Odd, all exponents will be odd. Simple as that. Watch the other video if you want a more technical mathematical explanation of it, but this is what's always worked for me. Again, when we get to other functions like trig functions and such, we need to get back to the graphing view of things. But for this first part where we're talking about polynomials, this will probably steer you all the way. Again, send me questions. I'd be happy to make up a quick little video, and let me know if they're helpful. That's what I'm doing them for. Thanks.